Hello everyone, my name is Haoyang Yu, and I'm an applications engineer for Keysight eSoft EDA. Today I'm going to show you how to set up ADS electrothermal simulation. The example that I'm going to use is a multi-technology workspace. So step number 1, go to your substrate definition. And if you have nested technology, go into it and make sure that you have all the heat sources defined. Go to File, Export, Thermotech Files. This will tell you that it'll overwrite all the existing files that you already have on file. Click OK. Step number 2, go to your nested technology and scroll down to heat sources. Make sure all your heat sources are checked here for nested technology. Step number 3, go to your top level bench setup. Go to the Electrothermal setup and make sure that we select the tech.tcl file that we just exported from our substrate editor. And then go to your top level schematic. Make sure that it has both a layout view and a schematic view. At this point, you're ready to run your simulation. Just to save some time, I already had the simulation run, and we can check the thermal result by going to Windows, open Thermal Viewer. Check this, and you will see the thermal results. This is a 2D view. By clicking any point, you can see the temperature on the lower left corner. You can also overlay the circuit on top of the thermal results. You can uncheck it, and you can go to a 3D view. In the 3D view, you can do X and Y sliders, and you can also move your reference plane up and down. In this case, it's showing the chip level now, but I can move it down to show the laminate level. And some of you guys may wonder, what if I don't have anything to begin with? How can I set up my ADS electrothermal simulation from the scratch? So now I'm going to generate a new workspace. Let's call it test. So we will generate a new layout called cell 1. And we're going to use the ADS standard layout resolution. First, open up your substrate editor. Let's create one. You already have a conductor defined. Let's make it a little bit more realistic. And then what you want to do is you want to map a new layer as your heat source. So here we're going to say heat source. And the layer purpose is going to be heat source. Click OK. And then go to your layer definitions, scroll down to the layer that you just defined, and make sure we give it some color. Save this. And because this is a legacy air, it doesn't have thermal properties, we're going to add the new air definition from our database. And we're going to use the new air definition here. So at this point, we can do File, Export, Thermotech file. So the reason it's giving us an error is because we're still using the perfect conductor. Let's select copper, and let's make sure that copper has thermal properties defined right here. Click OK. File, Export, Thermaltake file. Overwrite. So this time you see no errors or warnings. Let's close this. In the layout, let's go to the heat source layer that we just generated. Let's draw a rectangle. This is our layout. And for the simulator to know which component is corresponding to which layout, we also have to insert a text. And let's call it R1 because we're going to add a resistor to the simulation. Save the layout, and let's do a new schematic. And let's insert a resistor. And let's make it 1K. And let's give it a temperature coefficient. Then let's generate another schematic for our top level simulation bench. Let's drop in our cell 1, which is the resistor. Let's do a DC source. So let's run a DC simulation just to make it quick. And let's do the electrothermal controller. And let's select the tech file that we just generated. And normally, for the boundary conditions on the top surface, we want to make it super big because usually it's air on the top. And we want to make it super small on the bottom because it's usually a metal on the bottom. Click OK. Now we're ready to simulate. And as you can see, it's doing the iteration, which means it's electrothermal as opposed to thermal only. So a quick simulation is pretty fast. And here, because it's just a single resistor, you can see the temperature rise from 25 to 31.86 on the resistor. And if you look at the data plot, you can see the current. Thank you for watching.